Hey there, science fans. Today we're diving into the fascinating world of neoprene, a material known for its exceptional water resistance. Neoprene, also known as polychloroprene, is a synthetic rubber that's been making waves in various industries since its invention in 1930. This incredible material was born out of a need for oil-resistant rubber, and boy did it deliver. It's not just resistant to oil. Neoprene laughs in the face of water, making it perfect for applications where staying dry is key. Think wetsuits, waterproof gloves, and even laptop sleeves. But what gives neoprene its incredible water-repelling superpowers? The answer lies in its unique structure. Imagine a material made up of tiny closed cells filled with air. That's neoprene for you. These closed cells act like a fortress, preventing water from penetrating the material and keeping whatever's inside safe and dry. This unique structure is what makes neoprene the ultimate water resistance champion. So buckle up as we put neoprene to the test and unravel the science behind its incredible water-resistant properties. Get ready to be amazed. All right, science enthusiasts, let's kick off our neoprene exploration with a simple yet fascinating experiment. Today we'll be testing the water resistance of a smooth neoprene surface. Picture this. A pristine sheet of neoprene, smooth as a baby's bottom, ready to face the watery challenge. We carefully pour water onto its surface, our eyes glued to the action, and what do we see? The water, instead of seeping through, forms tiny beads on the neoprene like little shimmering pearls. These beads, reluctant to merge with the neoprene, roll effortlessly off the surface, leaving it bone dry. It's like watching water dance on a waterproof stage. This remarkable phenomenon occurs because of the air trapped within neoprene's closed cell structure. The air creates a barrier, preventing the water from penetrating the material. Think of it as an invisible shield, repelling the water molecules and keeping the neoprene high and dry. This impressive water resistance makes smooth neoprene perfect for applications where a sleek, watertight surface is crucial. From wetsuits gliding through the ocean to waterproof bags protecting your valuables, smooth neoprene stands strong against the elements. Hold on to your lab coats, folks, because things are about to get a little more complex. While smooth neoprene boasts impressive water resistance, seams are necessary to hold products together. How do seams affect water resistance? We'll investigate stitch seams. Imagine neat rows of stitches. We pour water over these seams. Here's where it gets interesting. Neoprene is highly water resistant, but stitching holes can allow water to seep through. Tiny pathways for water to sneak through. Manufacturers use clever solutions. Techniques like blind stitching and seam sealing minimize water penetration, ensuring water-resistant seams. Even with seams, neoprene remains a reliable choice for keeping things dry. Section 4. Texture trouble, water resistance, and textured neoprene. Welcome back, science aficionados. Today we're adding a twist to our neoprene adventure by exploring how texture affects its water resistance. Neoprene, in all its versatility, can come in various textures from embossed patterns to tiny perforations. This begs the question, do these textures compromise neoprene's ability to repel water? Let's find out. Imagine a piece of neoprene with a textured surface, perhaps with tiny bumps or ridges. We carefully pour water onto it, our eyes peeled for any changes in its behavior. Here's where things get intriguing. Depending on the type and size of the texture, we might observe slight variations in water resistance. For instance, a highly textured surface might trap small amounts of water within its crevices, while a smoother texture might shed water more readily. It's like creating a miniature landscape where water can pool or flow depending on the terrain. However, it's important to note that these variations are often minimal and don't necessarily compromise neoprene's overall water resistance. Section 5. Submerged and squeezed water retention in neoprene. Get ready for the grand finale, science buffs, as we put neoprene's water resistance to the ultimate test. We'll submerge a neoprene sample in water and give it a squeeze to see how much water it retains. Imagine this, a piece of neoprene bravely taking the plunge into water. We let it soak, allowing it to fully interact with its watery surroundings. After its aquatic adventure, we remove the neoprene and give it a gentle squeeze. Neoprene's closed cell structure prevents water from flooding through, but some water might get trapped. Think of it like a sponge absorbing water, but on a smaller scale. When we squeeze the neoprene, this trapped water is released. This is useful in wetsuits, where a thin layer of water helps with insulation. So there you have it, folks. Neoprene exhibits remarkable water resistance, making it ideal for staying dry. From waterproof bags to wetsuits, neoprene keeps water at bay. And that's the science behind neoprene's incredible water-resistant properties. Remember, keep experimenting and never stop exploring the wonders of science.